Assalamualaikum and hi. Do you know that cleaning also have energies? But before I explain detail on cleaning energies, I need to explain on the cleaning kinetics and then the reactions reactions that involve during cleaning. Yeah? There are various cleaning kinetics that have been derived. And that's cleaning kinetic. The variety of cleaning direct kinetics is depending on the type of soil of the research study, the cleaning methods, and the cleaning mechanisms that happen during the removal. Here is the first order cleaning model. That what I'm showing here is the first order cleaning model, which is the most accepted model. So this equation represents the rate of soil removals, okay, where M here stand for mass of soil per unit area, and K here is a constant which depends by the properties of soils, the surface of the substrate, the cleanness, the temperature, and the mechanical force, which here I mean by the shear force. Now let's look the cleaning reaction that may happen during cleaning. Cleaning reaction is actually heterogeneous reaction as the reactants are in different phases in the detergent solution and the salt deposit. The cleaning mechanisms start with bulk reaction where the cleaning chemical react with salt that disperse. That disperse or dissolve in the bulks. So this brown shaded oval represent the soil, and this red shaded oval represent the chemical compounds. And then these chemical compounds as well may react with the water hardness we represent by the blue shaded oval shape here. Okay, so the present of salts, the present of salts and the water hardness may reduce and weaken the cleaning chemical strength if there is high salts and high water hardness level. Okay, so this is not really a desired condition. Yeah? That's why pre-rinse step in cleaning and good quality potable water supply is important. If the water hardness condition not good, you need to choose detergent which has complex zinc and sequestering agents. The next step is transportation of the detergent. Okay, transportation of the detergent to the surface through the boundary layer. Okay, so this chemical compound is transferred to the surface through the boundary layer, and absorption between the solid, between the liquid, the absorption between the liquid and solid interface, right? The transportation is caused, okay, it is caused by it could be by the turbulent, it could be caused by the turbulent, or it could be caused by the concentration gradients. Then the next step is the detergents are transferred into the fouling deposit, and react with the deposit. This may happen by capillary and molecular diffusions. Surface active agents will accelerate this process and then weaken the deposit substrate bonds. Next is a cleaning reaction. This cleaning reaction occurs when cleaning compounds come in contact with the fouling deposit, and then the reaction can be divided into physical-chemical reaction. Okay, physical-chemical reaction. Physical-chemical reaction involves mechanical, melting, thermal stress, soaking, wetting, shrinking, swelling, dissolution, emulsification, deflocculation, and desorption. While for chemical reaction, okay, it might involve peptidization, saponification, solubilization, dispersion, suspending, sequestering, and chelation. This reaction will weaken. This reaction will weaken the cohesion force. Will weaken the cohesion force. Will weaken the cohesion force. Cohesion force between the sol and sol bonds, and adhesion force. And adhesion force. Adhesion forces between sol and substrate bond. So here in this illustration, our substrate is the stainless steel surface. Then the smaller molecules formed from the reaction will transport to interface. And finally, the product of cleaning reaction or the detachment of the salts will be transported to bulk solution through the boundary layer. Concentration gradients and turbulence can accelerate the process. The action of chemical reaction sometimes will induce the removal of big chunk of fouling deposit, and the flow of the cleaning solution may as well cause erosion at the fouling deposit surface. Cleaning rates are influenced by these three parameters. Okay, system, operation, and design and construction. So if you look here, under the system, what mean by the system is actually the system of the soil, and anything that may influence the cleaning. So here the soil type, soil condition, whether it's burnt soil, it's hardened soil, and then the soil amount, whether how much is the soil, is it very heavy soil, so many soils, and then water hardness, this referring to the water quality, and then the soil in cleaning solution. Then for operation, this is actually the operation here where it involves time, mechanical action, cleaning chemical, and temperature. I will explain after this, where this is actually referring also as is also known as cleaning energies. All right, and then the next parameters that might influence the cleaning rate is the design and construction of the cleaning and the cleaning equipment, and the equipment of the processing. So here the detail of it is the involved is the surface type, surface finishing, sorry for the spelling here, surface finishing and condition, and the equipment design. Okay. So now let's look at cleaning energies. So cleaning energies here is including time, mechanical action, chemical, and temperature. And this is always called as often called as TAC. the combination of these energies, TACT, the short form for it. Okay, so these cleaning energies are the core driver for efficient cleaning. The combination of time, the action, chemicals and temperature. It's involved the combination of time, action, chemical and temperature. And these four energies are interconnected and depending on each other. Time energies is referring to time needed to properly clean the surface. This cleaning time depend on the cleaning method, soil, and type of equipment. While for mechanical action can be generated by the action of brushing, water jets, and turbulent flow in pipes. This cleaning action will transfer the cleaning compounds to the soil and accelerate the removal. A flow rate of about 1.5 meter per second is needed to create a turbulent flow inside a pipe. So then let's look on the chemical energy. So let me jot down something here. Okay, this normally we prefer as for cleaning is for cleaning for the best flow rate to induce mechanical action. Ni flow rate inside the pipe is 25 meter per second. Okay, meter per second. And okay, now let's look on the chemical energy. Chemical energy will depend on type of chemical and the concentration. Okay, and then temperature energy is usually in the form of hot water or steam, right? For the temperature increment increase, with the temperature increment, it will increase the chemical reaction rate. Okay, the rule of thumb is for every okay, for every 10 degrees Celsius of increment, you will double. You will double up the chemical reaction. We will double the chemical reaction. Okay. So, and I would like to note as well that in order for you to control the uh, uh, what to call it, this the flow rate, the flow rate inside the pipe is also depend. Remember, it also depend on the pipe diameter. So this is an example of volume flow needed to volume flow needed to achieve 1.5 meter per second in different pipe diameters. All right. So if you can see here that different size, different diameters will influence the flow, the flow rate needed in order for you to achieve this velocity, liquid velocity. This liquid velocity is needed in order for you to reach the desired velocity, and that will ensure that you will get a sufficient mechanical action. Okay, right. So, take this table are from Tetra Pak Handbook Cleaning in Place. Okay, I think that's enough for this video. All right. So we shall meet in other video with other different contents. Okay, thank you. Bye. Assalamualaikum.